You are good.
Is that actually how their name?
Work it, Mr. Manfred.
Rule number one, the derivative of a constant. And Connor, you asked if that's if it's really that's what the name of it is. And this is what the name of it is, okay? Our book numbers them 1 through 7, so I'm just going to stay consistent with the book. All right, rule number one, the derivative of a constant, which should not be anything earth-shattering. Because what is a derivative? Slope. So if I gave you f of x equals 3, okay, that's a constant. That's a horizontal line. What's the slope of a horizontal line?
0.
0. So I would say the derivative of this is 0. The derivative of any constant is a 0. So we can write that this way. The derivative of a constant with respect to x is equal to 0. Okay? The derivative of a constant with respect to x is 0. That's rule number one. It's the easiest rule there is. All right? Rule number two. This is the shortcut rule. This is the power rule. Okay? This is the power rule. Our book breaks it up into the power rule for positive integers and negative integers. This is the one for positive integers, but it's the same for both. Basically, if n is a positive integer, then the derivative of x to the n with respect to x is equal to n times x raised to the n minus 1. That's the shortcut that most of you have been using. Okay? That's the shortcut that most of you have been using. So for example, this easiest, most basic example there is, if I say f of x equals x squared. That's a function. It's a parabola. Slope changes. Okay. The derivative of this, so f prime of x is equal to, I bring the power down in front, so it becomes 2 times x raised to the 2 minus 1 power. What's 2 minus 1?
1.
It's 1. So this becomes 2x to the first, or since we are in AP Calculus, we can just write it as 2x. Okay? That's okay. We don't have to write x to the first. Right, Anthony? Yes. This is the big one. Okay? This is a big one. That's the one that all of you have been using somewhat of. Now I'm going to expect that all of you use it from here on out. We will no longer use the definition of a derivative to find the derivative. We will start to use all of these rules combined, which makes life a whole heck of a lot easier to find the derivative. Okay?